Casey, the Senior Wastewater Treatment Operator at the Wastewater Treatment Plant. You can tell this room is very noisy. Okay, Casey, what have we got here?
Well, as you saw earlier, when you saw the aeration tanks, the bugs require food and air to do their thing. So these are the blowers that provide air for the wastewater process. Outside, you can't see them because they're deep in the tanks. There's a series of membrane cassettes, and they look like this. They're about the size of a Volkswagen, and there's 6 of them in each train, and there's 6 trains. Each cassette has 48 of these modules in it. These are the magic, these are the hollow fiber modules. They have a nominal pore size of 0.04 micron, which will hold back all known bacteria and most viruses when you filter it. So we apply a light draw to the inside of these membranes, just like you would suck on a straw, and it filters all of that nasty stuff. All of the biomass stays on the outside, and the clear water is drawn through the pores of the membrane and sent to the effluent room for our final effluent. These membranes are submerged in the tank, and the biomass runs through there, and depending on the flow, we might run 1 train, 2 trains, 3 trains, all the way up to 6 at peak flow to pull that water out of that biomass, because the water is coming in continuously. So let's go have a look at where the final effluent is. This is our final effluent room, and this is where we do our UV sterilization. Because our effluent is so clean, we don't really need the UV sterilization, but if there was any catastrophic failure, the UV is the final step before the water leaves the plant. It's required by ecology, and it's just a good idea. In case we have any trouble with the process, nothing will escape the plant alive.
Is this the water that I hear running through here?
Yes, ma'am. That's our effluent flow. It's exactly the same amount that's coming into the plant at any given moment is coming out here. You can see the glow of the ultraviolet. The ultraviolet sterilization. There's 3 banks. And run at a very, very high energy level, and the ultraviolet breaks these chains so that any bacteria or viruses cannot reproduce. Saw what came into the plant. Hold on just a second. Take a look at what comes out of the process. From that brown biomass full of bugs and food.
So you're telling me that first picture we saw in one of those other pictures, that's what this is now?
Correct.
Amazing.
See if there's any smell.
Nope, I smell nothing, Casey.
It's almost pure enough to drink. Another couple of polishing steps and this would be potable water.
Well, it's cleaner than most water in the world that many people drink.
It is cleaner than the slough that we put it into. We're putting in a super clean water, a neutral pH, no real nasties in it, just good stuff to put back in the environment, water the plants and the fishes.
And this is a membrane treatment plant. That's what helps clean it so well.
Membrane bioreactors, that's what does it. The membrane is head and shoulders above most treatment processes. Because of that, we can produce a very high quality effluent in a very small footprint.
That's amazing. Thank you, Casey.